Alright friends, welcome back. In this video we're going to go ahead and take a look at the next section of your prerequisites chapter, which is P.3. And in this video what I want to do is talk all about polynomials. I want to talk about what they are, how we point out certain characteristics of them, to classify them, how to name them. But more specifically in this video I want the meat to be how we do operations with them. So how specifically do we add and subtract polynomials, and then after that we'll take a look at a couple of examples of multiplying polynomials. So first, before we get started, I want to kind of examine the actual word polynomials. So the beginning of the word poly, this is something that of course means many. Okay, so when you say that you have a polynomial, you have many of something. What do we have many of? Well, we have many nomials. And nomials are a fancy word for terms. So when you say you have polynomials, you're mentioning that you have something with many terms. And just to be clear here, when we say terms, what we mean is that these are the parts of the expression that are separated by plus or minus signs. Okay, so I might just make a note of that here. These are parts that are separated by plus or minus signs in your expression. Okay, so for example, if I were to take a look at this one down here and point out all of the plus or minus signs I've got this minus sign, I've got this plus sign, and I've got this minus sign. That must mean I have 1, 2, 3, 4 terms in this polynomial. Okay, so that would be a 4-term polynomial. Okay, and now that we know what it is, it's just an algebraic expression with a certain number of terms, many terms. There are a couple of different types of polynomials that I want us to be familiar with, right? We stick with this naming convention of whenever we have a 1-term, we use the prefix mono to mean 1. Whenever we have a 2-term, we use the prefix bi, which means 2, like a bicycle has 2 wheels. 3 terms, tri, like a tricycle has 3 wheels. And then after that, we just stick with the prefix poly. Okay, so polynomial if your number of terms is 3 or more. In the case where we have 1 term, we call that a monomial. 2 terms would be a binomial, and 3 terms would be a trinomial. So if we use these words in future videos or in this video, that's what we mean, is a polynomial with that many terms in it. Okay, and so a couple of key characteristics that we would maybe want to point out here. First of all, whenever we point out it says here the term, what we mean to say here is the leading term. For whatever reason, that did not run off correctly on my notes here. But the leading term would be the term of our polynomial that comes first whenever we reorder everything so that the exponents decrease as you go from left to right. And so for us here, that would be this first term right here, the 3x to the 4th. That would be our leading term. Okay? As far as a leading coefficient, that would be the number in front of our leading term. Okay, so anytime it says coefficient, that's what it's talking about, is you're simply just referring to the number in front of your variable. And here for us, that is simply just going to be the number 3, and so the leading coefficient is going to be a 3. Moving on, the constant term. What a constant term is the term of our polynomial that remains constant no matter what x happens to be. Okay, and so here in this polynomial, that term would be the very last term, 13. Okay, or I should say negative 13 here in this example. And again, that's because if we start plugging in numerous values for x, since it's a variable, the only one that doesn't have an x next to it is 13, so that stays constantly a minus 13 no matter what we plug in for x. And then finally, there's the degree of the polynomial. What that is it's the largest exponent that you see in the entire polynomial. And here it's really easy to point out. That would just simply be 4. Okay? And so these are key characteristics of polynomials that we will go ahead and point out in the future. Specifically, they come into play whenever we want to do things with polynomials, like graph them and that kind of thing. But for right now, we're just going to go ahead and point these out. Next here, a little bit more about what makes a polynomial a polynomial. When you have a polynomial, you are always going to see that it has real number coefficients, so no imaginary number coefficients. The number I is not going to show up whenever you have a polynomial. And also, your exponents are always going to be non-negative, okay? So if you see an expression with a negative exponent in it, by definition, it's not a polynomial. We only want positive exponents or 0 as an exponent. Okay, and so now that we know what a polynomial is, what I want to do is take a little bit of time and introduce how we might add or subtract polynomials. And so a little bit of a descriptive sentence here. It says we would want to add or subtract the coefficients on terms where the variables are the same. And I'm going to actually box that here because that's the most important part, is we need to identify variables that are the same, because essentially what this is saying is that we need to simply combine like terms. And so you guys have been doing that in your algebra classes for a long time now, is combining like terms. And so that's how we're going to check to see if they are like terms, is if their variable parts are identically matching. Okay? And so let's go through first and identify some problems here. Now, the first thing that you may notice is that we have some parentheses here in this example, and it's important that we discuss when are they needed versus when are they not needed, right? When can we drop them? Well, it turns out if you have a negative sign in front of your set of parentheses, then we would need to distribute in that negative, okay? If there's anything else in front of your parentheses, then you can just go ahead and drop the parentheses. So really the only time we absolutely need to have grouping symbols is if there is a negative in front that we would need to distribute in. So in all these examples where we don't have a negative in front, I'm just going to go ahead and drop the parentheses, and we're going to go ahead and move on. If we do have a negative out front, we'll distribute that into everything inside the parentheses and then continue on with these exact same steps here, okay? So in number 1, you see that I just used my whiteout pen and I just dropped my parentheses there, no problem. And now I'm looking for like terms. I'm looking at the variable parts and I'm looking for ones that identically match. And so in number 1 here, I've got 6x to the third, and then later on in the expression, I've got plus 4x to the third. Those have identically matching variable parts, and so I would go ahead and say here that I can combine them. 6 plus 4 makes 10. X to the third. Okay. Next up, I've got some straight up x terms, x to the first. That is a positive 3x minus 2x. And you notice that I highlighted the signs in front of these numbers and read that off as positive 3, negative 2. That's a good habit to get into, is watching your signs, right? So positive 3x minus 2x, that's going to give us a positive 1x. And keep in mind, whenever we have a coefficient of positive 1, we typically don't write the 1 in front. We just go ahead and leave it off because it is implied. Okay, and that would be a complete problem there for number 1. So pretty simple, we're just combining like terms. Number 2, we definitely see here that we have some more parentheses, and if you look closely, we do have a negative sign in front of this set of parentheses, so we're just going to go have to distribute that in. And again, that's just going to change the sign of everything in that set of parentheses specifically. So I might say that I've got here negative 2x squared minus 1. In front of that second set of parentheses is just a plus sign, and that's not a negative sign, so I can go ahead and freely drop these parentheses here and just continue to write plus 4x squared minus 2x. And now here I am going to identify my my like terms here. I've got some x squared terms. Specifically, I've got negative 2x squared plus 4x squared. That's going to give me positive 2x squared. And then after that, I'm going to go ahead and look for the next type of term that I have by going 1 down on my exponent. So if I just did my x squared terms, I'm going to go ahead and now look for my x to the first terms. Okay? And really, there is only one of them. Here, it's just the negative 2x here, and there's not another x to the first term to combine with, so I'm just going to go ahead and copy it down. And finally, we have the constant term, which is the x to the 0 power term, or in other words, the one without an x next to it. That would just simply be minus 1 there in this example, okay? And so once you have combined everything and you have written all of your exponents on your x's in decreasing order as you read from left to right, which is called standard form of a polynomial, by the way, that means you're all finished up. Okay, so moving on to some other examples here. Number 3, our polynomials can get longer with more terms, but it doesn't mean that anything changes. We're going to look at our grouping symbols first. It turns out that we can go ahead and drop these because we don't see any negatives out front, so I'll just white those out really quick. And then we'll go through and identify some like terms and combine those up. Okay, so the largest exponent that I see on an x here in this expression is an x to the third term. So that's maybe where I will start. So I have a 5x to the third. As I continue to scan through, I've got a plus x to the third and no other x to the third terms to speak of here. So that's 5 of them plus 1 more. That's going to give us 6x to the third terms. And moving right along, I might go ahead and move on to my x squared terms. Again, just take that exponent and go 1 down. We're going to write this in standard form. So I've got some x squared terms here to talk about. That's negative 7x squared plus 2x squared. That is going to give us negative 5x squared. Next, we'll move on to our x terms here. Do that in a different color. As I scan through, it looks like I only have one of those. So I just have a simple minus x, which I'll go ahead and copy down. And then finally, I've got my constant terms here. So I've got my negative 3 plus my 8. I'm going to go ahead and combine those. That's going to give me a positive 5 when I'm all said and done there. And so None of these remaining terms here in my expression are like terms. It's all in descending order with the exponents, so I'm just going to go ahead and call that my answer. Here in this next example, can we drop the grouping symbols? Well, we can drop this first set because there's not a negative sitting in front of that set of parentheses there, but we do have to be careful on the second set because there is a negative sitting in front of those parentheses. So we'll go ahead and distribute that in real fast to every single term that shows up inside those parentheses. And again, that's just going to effectively change the sign of all of the terms that are inside there. So minus 7x to the 6th minus 4x squared plus 4x minus 2. And then, of course, I still have my x to the 6th minus 3x squared plus 3 in the very beginning. Okay, and so now I'm just going to go through and identify some of my like terms and start combining. So I have some x to the 6th terms. I've got x to the 6th minus 7x to the 6th. It's going to give me negative 6x to the 6th. Moving right along, I might go ahead and move down to, it looks like the next highest exponent is an exponent of 2. So here I'm going to have a negative 3x squared minus 4x squared. That's going to give me minus 7x squared. Moving on, the next highest exponent that I see is just my x to the first, so that I just have one term of. That's going to be a plus 4x, which I'll just copy down. And then finally, we've got our constants here. So I've got positive 3, take away 2. That's going to give me a positive 1. Okay, so writing all of our terms in descending order with those exponents, that's what I'm going to end up here within this example. In this next one, number 5 here, we have a whole mess of grouping symbols, but again, it's important to remember that we can drop them as long as there's not a negative in front. If there is a negative in front, we got to distribute it in. So this first set of parentheses, I believe we could just go ahead and get rid of those because there's not a negative in front. And then you see these square brackets, okay? So in front of these square brackets, that's just a different type of grouping symbol. They could have just as easily put more parentheses there, but then we're staring at a whole mess of parentheses. So typically we like to kind of switch it up a little bit and do some different grouping symbols. You definitely do see a negative sign in front of that set of square brackets there, and that will be something that we will need to distribute in to everything that's on the inside. But maybe let's take a look at in between those square brackets, and because I see some more parentheses, let's figure out if we need them. In front of these sets of parentheses, I don't see any negative signs, so we could just go ahead and get rid of these sets of parentheses. And then what we can do is think about this negative distributing to all 4 terms of that polynomial inside the square brackets, okay? And that's just going to effectively change the sign of everything. So here in my next line, I'm going to go ahead and copy down my y cubed plus 1, and then distribute that negative into everything. That'll be negative y squared minus 1 minus 3y, and then plus 7. Remember, a negative times a negative is always going to equal a positive for us. And so that's why I wrote the plus 7. And then we're going to go through. You might notice that we don't really have any like terms here that have a y in it. The y cubed term is by itself. The negative y squared term is also by itself. There's no other like terms that it can combine with, and it's the same thing with the minus 3y. However, we do have a bunch of constants that we can go through and combine here. So that'll be positive 1, minus 1, plus 7. If you do that math mentally, the positive 1 and the negative 1, that'll make 0, and that just simply leaves you with the plus 7 there at the very end to tack on. Okay, so when you guys are adding and subtracting polynomials, you can see all my color here. It's just a matter of dropping the parentheses when you can. Again, when you have a negative in front of your set of parentheses, you have to distribute that into all your terms. And then after that, it's just identifying what variable parts are the exact same so that you can go ahead and add the numbers that are in front of those x terms and successfully add or subtract your polynomials. Okay. Another type of operation that I want to take a look at here in this video is multiplying polynomials. And the thing with this is that it could look different depending on the type of polynomials you're trying to multiply, okay? So I think the easiest case of multiplying polynomials is that case where you have a monomial times a polynomial, right? So like in number 6 here, I've got the monomial 3x times that trinomial there. In number 7, I've got this monomial, the 1/2 x, that's the monomial. And what we're going to simply do with these is we're going to go ahead and distribute those into all of the terms of your trinomial. So lots of distributed property here today. Okay, and so let's just go ahead and do that here really quickly. Whenever we're multiplying, we need to remember that we're going to multiply the coefficients together, and then we're going to have to remember what happens with the exponents whenever we multiply like bases of x. So maybe let's go ahead and zoom in on number 6 here and talk about how that's done, right? So if I do that first distribution, the 3x times 2x to the 4th, that would be 3 times 2, which makes 6. And then on the 3x on the outside, that monomial, that's 3x to the 1st. So when you multiply x to first times x to the fourth, remember that those are like bases that we're multiplying so that we add those exponents, right? So that'll be 1 plus 4, or in other words, an exponent of 5, okay? Doing that next distribution, we're going to have 3 times negative 7. That'll give us negative 21. And then x to the first times x squared is going to be, add those exponents, so it's going to be x to the third here, okay? And then finally, that third distribution, that's just taking the monomial 3x and multiplying it times 3, and that's just simply going to give us 9x. And there is our final answer right there. Okay, so super simple to do. Let's take a look at this next one, right, where we said we have the monomial 1/2 x. We're going to distribute that to everything. So if we distribute that to the first little term of that trinomial there, that's going to be 1/2 times 3, in other words, 3 over 2. This is x to the first on the outside, so that's x to the first times x squared. That'll give us x to the third. And then we can go ahead and do the distribution to the second term there. So that's 1/2 x times negative 4x. That'll give us negative 2x squared. And then finally do that last distribution there, the 1/2 x times 6. That'll give you plus 3x. Okay? So super simple. Whenever you have a monomial times a polynomial, you would just need to go ahead and apply distributive property to that problem. Even on ones like this, where even though we do have a monomial out front, it does have a couple of different variable terms in it, but that doesn't mean that anything changes. We're still going to do the exact same thing. It's just now we have more bases to multiply and more exponents to add, okay? So multiply those coefficients. I'm just going to do this one really quickly. Negative 5 times 3, that's negative 15. X to the first times x to the second is x to the third. Y to the second times y to the third, that's going to be y to the fifth, okay? Distribute to that middle term. So we're going to have negative 5 times positive 5. That'll give us negative 25. X to the first times x is x squared. Y to the second times y to the seventh, add those exponents, that's going to be y to the ninth. And then we'll finally do that last distribution there, so that'll be a negative 5 times a negative 4. A negative times a negative makes a positive, and so 5 times 4 makes 20. There we go. You'll notice that the term here does not have an x term in it, so we're just going to go ahead and copy down the x to the first term that shows up in the monomial in green. And then finally, y to the second times y to the fourth, add those exponents, that would be y to the sixth. Okay, so really quickly, what I want to kind of identify here is that none of our variable parts are going to match here, right? You've got x to the third, y to the fifth here. You've got x to the second, y to the ninth there. And you got x to the first, y to the sixth there. None of those variable parts have identically matching bases with exponents. And so for that reason, none of these terms would be considered to be like terms. And we would just go ahead and box this straight away, okay, as our final result. On number 9 here, we have some more distributive property to do. It looks like we have this monomial 4x, and of course you know what the deal is by now. We're going to distribute that in. But then as you look further into your expression, we also have this other monomial, this negative 5x squared. We're going to distribute that to the trinomial that it is being multiplied times. Okay, so really simply to do, let's just go ahead and keep my colors the same here. If I distribute that 4x inside of that binomial there, we're going to get 4x minus 4x to the fourth, adding those exponents. And then if we move on to that blue distribution here, we're going to have negative 5x to the fourth, positive 5x to the third, and negative 20x squared. Okay, so hopefully the color works out for you there. It would be at this point that we would just want to kind of quickly identify where we've got some like terms going on, and I definitely think that we can find some if we look right there at our second and third term of this expression. We have some x to the fourth terms, and we have negative 4 minus 5. That's simply just going to give us negative 9x to the fourth, and then we're just going to follow it up with each of our terms that have descending exponents. So we're going to pick up here with the x to the third term, so plus 5x to the third, minus 20x squared, plus 4x. And there is our final result. So it's the easiest, again, whenever you take a monomial and you multiply it times a polynomial. You would just want to distribute that monomial to all the terms of your polynomial and then combine any like terms that you've got. But where this is going to start to get more challenging is when we start to multiply different types of polynomials together. And so what we might be interested in here are a couple of special products formulas that kind of act as shortcuts whenever we notice that they can be applied. Okay, and so I'll go ahead and say that here. These are very similar to just simple shortcuts that we can apply whenever we notice that our examples have any one of these forms. And so that's the way I want you to think about it is if you were looking at your example and you notice that you have any example that is of any of these forms here that are on the left, then what that means is that you can automatically just simply apply this formula and you don't need to do any of that messy distributive property or foiling or anything like that, okay? So that is how these work. If you look at your examples, you notice that you've got one of these going on, you could feel free to just go ahead and write what it says on the reverse side of the equal sign. And even on this second and third structure, I might even encourage you to look out for these. Because again, if you notice that you've got that sort of thing going on, you can just immediately apply what it says on the other side of the equal sign as some shortcuts for you. So we're going to see that here in a little bit. Another thing that we need to be on the lookout for is any time we have a binomial times a binomial. That is another special case. Okay, so any two-term polynomial times any other two-term polynomial, anytime you guys have that, I'll say here if you have that structure, then you can simply just go ahead and FOIL. Okay, so FOIL method is something that a lot of people have discussed in earlier algebra courses, and we'll see an example of that whenever we get to it. Okay, so if it is not one of these special product formulas or shortcuts, and it's not a binomial times a binomial, we are going to just have to go ahead and trudge through all of that tedious distributive property to figure out what our final answer would be here. But let's take a look at a couple of examples and let's identify where we can use these shortcuts, right? So number 10, you have x plus 4 times x minus 4. If you notice here, you've got something that really closely matches that first form that you have in your list of formulas. This is something that looks an awful lot like u plus v times u minus v. Okay, and so because we notice that it matches that structure, we're just going to go ahead and apply the shortcut, which says that if I have this structure, it's automatically equal to whatever u is squared minus whatever v is squared. Okay, and so you may notice that playing the role of u is just simply x, so I'll just simply say here x squared, and playing the role of v is simply going to be 4, so I'm going to say minus 4 squared. Okay, and that's our final answer. With the exception of doing 4 squared, I would like you to go ahead and actually do the evaluating whenever is possible. And so our final answer here would simply just be x squared minus 16. In the next example here, we have something that looks an awful lot like u minus v all squared from your list of special shortcuts up at the top. And if you notice that you've got that, then what you can go ahead and apply here is simply just saying that this is equal to u squared minus 2 times u times v plus v squared at the very end. Okay? The only trouble here is you need to be able to notice that you've got this form when you see it, and then you also need to be able to pick out what's playing the role of u and what's playing the role of v in these expressions, okay? So I want you to notice the form that we have matching up here. Both of these have the minus sign in between, and they both have that exponent of 2. So basically, this is the square of a difference formula. And when you're trying to figure out what's playing the role of what, we just have to look at what's on either side of that minus sign. So playing the role of u today is simply just going to be 2x, and playing the role of v today is going to be y, okay? So what I might do is I might write out this formula, leaving me some spaces so that I can go ahead and start to substitute in what's playing the role of u and v respectively, okay? And so playing the role of u, we said, was 2x, so I'll go ahead and write that everywhere I see a u, and playing the role of v, of course, is this y, so I'll go ahead and substitute there. Okay, so the shortcut got us to this point, and again, this prevents us from having to write out 2 copies of this binomial and FOIL everything out. Okay, but we do need to know how this simplifies, and so for that, we may need to recall our order of operations. So please excuse my dear Aunt Sally. Is how a lot of people memorize this. The P, of course, stands for parentheses. So if there's anything to do inside of the parentheses that we wrote, we would need to take care of that first before jumping out of those parentheses and moving on to other things. Well, inside of our parentheses here, we just have the monomial 2x or we have y. There's really nothing to do with those specifically, so we're just going to go ahead and move on to exponents. Okay, so that's what the E stands for. And we definitely have some exponent terms here, right? We have the monomial 2x in front that's being squared. So everything inside that set of parentheses is being squared. 2 squared is 4, and x squared we'll write as x squared. And then at the very end, we can go ahead and just simply drop those parentheses there on that y and just call that y squared simply. That middle part I'm going to go ahead and save here for when we move on in our order of operations. We are done with the exponents part, and now we move on to multiplications and divisions, taking care of whatever comes first as we read the expression from left to right. Here we don't really have any divisions, but we do have a multiplication. We have this middle term right here that we're multiplying three different terms there. And so we're going to talk about how we're going to simplify that or work that out, right? So the way that you want to do that is you would simply just want to multiply the coefficients together. So we have negative 2 times 2, and that'll simply give us a 4. So I'm going to lead this off with our 4x squared, but then pick back up with the negative 2 times 2. That's going to be negative 4, and then you'll see what's left over in the multiplication is just simply a copy of x and a copy of y. So I'm just going to write that as negative 4xy, and then follow up with my plus y squared at the very end. Okay, so we have finished all of the multiplications and divisions, and then we finally move on to additions and subtractions, whatever comes first as you scan from left to right. And we do see a minus sign and a plus sign here in the mix, but remember that we can only combine these if the variable parts are identical, and here they are not. So we're just going to go ahead and box this as our final result in the problem. Okay, so when you apply a shortcut, you're going to need to keep in mind your order of operations for simplifying what you end up with after you apply your shortcut. Number 12 here, if you try to match this up to one of your forms in the list in the top part of the page, you're not going to be able to really match this up to anything. So what that is going to mean here is that we are going to FOIL this out because we have a binomial times a binomial. Okay, and so just to kind of again talk about the way that this works, we would just simply go ahead, and the F for FOIL stands for multiply the term that comes first times the term that comes first in the other binomial. That's your F part. So that's a 5x times a 4x. That'll give us 20x squared, which I'll try to write here a little bit neater. There we go. Multiply the outer terms. That's going to be 5x times 5. That'll give you your outer terms. That's going to give you 25x. Multiply your inner terms for your I part in FOIL. That's going to be 4 times 4x, or in other words, 16x. And then finally multiply the terms that come last. That's going to be a 4 times a 5, and that's going to simply give us a 20. Okay? Now, about 95% of the time, I would say, your outer and your inners are actually going to be like terms that you can combine into a single term of your polynomial. And here that's the exact same case here as well. So always check for that. And our final answer here is going to be 20x squared plus 41x when you add those together plus 20, and that will complete the problem. Okay? So sometimes you're going to have some examples that do not match one of the formulas from up top, and so we're going to have to employ other methods like FOIL method here. Okay? Number 13, this is something that very closely matches u minus v cubed. And so whenever you apply the formula for this, it would be u cubed minus 3u squared y plus 3uy squared. Or what am I talking about? Y here. We're dealing with v, right? So I should be saying v instead of y. I apologize. And then finally, following that up with a minus v cubed. Okay? And so what I might do here is just go ahead and simply, again, leave myself some space here. And I'm not going to go ahead and do this entire example with you here just for the sake of time in the video, but it would just be the exact same as number 11 that came before it, where I would go ahead and leave myself some spaces here for the various parts that I would want to substitute in my expression, and then maybe just going ahead and pointing out what's playing the role of u and v respectively. So playing the role of u, what comes before the minus sign, that's the 2x. So everywhere I see a u, I'm going to go ahead and put in a 2x. And so we see that sitting in a bunch of places here in this formula, so we'll go ahead and put that down. And then playing the role of v, of course, is what comes after the minus sign, and that's going to be 3 here. So we're going to plug in a 3 here as well. And there we go. There is the setup. Now, I'm not going to go ahead and discuss the rest of that just because that's something that I want to kind of save some time in the video for. But I will go ahead and share with you what this finally expands down into, because if you want to do this on your own later, might be something good to check yourself with. But I will share with you here that what you should be getting after you simplify everything is going to be 8x cubed minus 36x squared plus 54x minus 27. Okay, and so again, I'm going to go ahead and skip on that work for the sake of the video length, but if you wanted to do that one on your own, that's what you would end up with there. Okay. For this next example here, again, if you try to match this up to one of your special forms, I don't believe you're going to be able to get this to match up to anything. So this is one where we are not going to be able to use the FOIL method because this is not a binomial times a binomial. Instead, we have a binomial times a trinomial. Okay, and so what we're going to need to do is just a whole mess of distributive property here, which I say is a whole mess, but really it's not even that hard. All we have to do is just be organized and clear in our work. So here's how this is going to go, right? We're going to go ahead and take the first term of the binomial, and we're going to begin to distribute it to every single term of the trinomial as a first step, okay? And so I'm just going to go ahead and blaze through that. That's going to be a 2x squared times a 4x to the 4th. That's going to give us 8x to the 6th. Do the next distribution there, so that's going to be 2 times negative 6x squared. So it'll give us negative 12x to the 4th. And then finally, the last distribution there in green, we're going to go ahead and do 2x squared times a 9. That's going to give us positive 18x squared. Okay? Moving right along here, we have our next term of our binomial, which is a positive 3. We're going to distribute that to every term of this trinomial. So 3 times 4x to the 4th, that'll give us a positive 12x to the 4th. When we do the next distribution there, 3 times negative 6x squared, that's going to give us negative 18x squared. And then finally, when we do that last distribution, that's positive 3 times positive 9. That'll give us positive 27. Okay? And so hopefully the color works for you there. Again, we're basically just doing distributive property twice. Some people call this double distributive property. But I want you to check out what happens here. Okay? In this example, we have some x to the 4th terms, right? So we've got negative 12x to the 4th. Plus 12x to the 4th, and you'll notice that if we were to try to combine those would just simply make 0, and that would fall out of the problem for us. So these terms are going to disappear whenever they combine together, and it turns out to work the exact same way for your x squared terms in this example as well. We have a positive 18 minus 18, and so that is going to combine and create 0 in the problem here as well. So apparently all 4 of those middle terms are just going to combine together and make 0, and all we're simply left here is simply the 8x to the 6th from out front, and then the plus 27 from there in the back there. So this is going to be our final result for that problem. Okay, so always check and see what like terms you have that can be combined, and then we'll move on to this last example here. Okay, so this is one where we have a whole mess of grouping symbols, and before, whenever we were doing adding, subtracting, we said that you could drop the grouping symbols when you're adding and subtracting. That's not the case here when we're multiplying. We're going to have to keep the grouping symbols here, but what I want you to notice is that we do have something of the form u plus v times that same u minus v, okay? It's just now they show up in a pair of square brackets instead of in a pair of parentheses like they said in the special product form from earlier. But that doesn't mean that anything changes. We do have this form, so according to the shortcut formula, this is just going to be equal to whatever u is squared minus whatever v is squared. Okay, so we're going to go ahead and apply that. Playing the role of u, it's going to turn out, again, you're looking at the quantity before the plus or before the minus. That's simply just going to be this binomial here. Okay, so this whole binomial, x minus 3, that is going to be what is playing the role of u. And apparently I have to square that in my formula. So I'm going to go ahead and take the binomial in parentheses and square that whole thing. Okay, and then according to my shortcut formula here, I'm going to say minus whatever's playing the role of v squared. That's the part that comes after the plus and after the minus, of course. And here that's just the variable y, and so I'll say y squared there. Okay, so that is what we're going to have according to our shortcut, and if we were to go ahead and continue to simplify this, keep in mind that x minus 3 squared, that's something that fits another one of our product formulas as well. That's something that fits u minus v squared. And so if you apply the formula for that, what you would end up with here is x squared minus 6x plus 9, and then there's the minus y squared from the very end. Okay, so I didn't really elaborate too much on where the x squared minus 6x plus 9 came from. I will just share with you that that is what we get whenever we apply that other product formula from up top, the u minus v quantity squared, and that's going to be our final result there at the very end. So I hope that this video has been of some help to you whenever you're multiplying and adding and subtracting polynomials. It's very simply, straightforwardly done. Maybe just involves a little bit of work, but that's all I have for this video. Thank you very much for your attention, and I will speak to you guys in the next one.